It's Sol 738 for Perseverance, another day of exploration on the Red Planet. The rover continues its vital mission, traversing the Martian landscape, seeking answers to questions that have intrigued scientists for decades. Perseverance finds itself in Jezero Crater, a place that was once a massive Martian lake billions of years ago. This ancient lakebed is a prime location to search for signs of past microbial life, a key objective of the mission. The dried lake offers a unique window into Mars's geological history. The rover's routine is interrupted. Day in and day out, Perseverance diligently carries out its programmed tasks, but sometimes the unexpected occurs, when its cameras spot a rock with striking alternating bands. This unusual rock stands out against the surrounding terrain, immediately piquing the interest of the rover's onboard systems. So unusual it immediately becomes a top priority. The automated systems flag the rock as a potential object of scientific interest, overriding the planned route. The science team at NASA's Jet Propulsion Lab back on Earth are alerted to the anomaly. Excitement ripples through the control room as they analyze the initial images. Quickly reroutes the rover for a closer look. The team works swiftly, sending new instructions to Perseverance, guiding it towards the intriguing rock. Every command is carefully planned, ensuring the rover's safety and maximizing the scientific return. The engineers meticulously review each step, simulating the rover's movements before sending the instructions. But this discovery is too important to pass by. The potential insights it could offer into Mars's past are too significant to ignore. This wasn't just another rock, it was something truly special. It was a geological anomaly, a puzzle piece in the grand story of Mars. A jackpot for planetary scientists, offering a rare opportunity to study a unique Martian formation. Perseverance, acting as our eyes and curiosity on Mars, continues to amaze us with its discoveries. Had stumbled onto a clue that could unlock Mars's ancient secrets, potentially revealing information about the planet's past habitability. Sometimes the universe rewards curiosity and the pursuit of knowledge. With a striped surprise, a reminder that there are still countless wonders waiting to be discovered on Mars. So what exactly is zebra rock? What secrets does it hold within its striped layers? It's classified as an igneous rock, a type of rock formed from the cooling and solidification of magma or molten rock deep beneath the surface. This process can take thousands, even millions of years. What makes zebra rock so unique are its distinct, almost painted-on stripes. These alternating bands of light and dark minerals create a striking visual pattern, a geological barcode of sorts. The pattern isn't random or haphazard, it's a carefully constructed layered structure like pages in a geological history book. Each layer tells a story. Each band is a record of a specific event in Mars's volcanic history, a snapshot in time preserved in stone. These bands offer clues about the planet's past climate, volcanic activity, and even the presence of water. The stripes vary in thickness, some are bold and pronounced, others are thin and delicate. They undulate and curve across the surface, creating a mesmerizing visual effect. This variation hints at a cyclical, fluctuating formation process, suggesting that the conditions under which the rock formed were not constant but rather changed over time. Over billions of years, Martian winds carrying fine grains of sand have relentlessly sandblasted the rock, sculpting its surface and revealing its hidden depths. This erosion has gradually worn away the outer layers, exposing its internal structure and allowing us to peer into its past. Zebra rock, as we see it today, is likely a fragment, a piece broken off from a much larger, more extensive geological formation. And now, by sheer chance, it's perfectly cross-sectioned, offering us a unique opportunity to study its intricate details and unravel its mysteries. It's a beautiful accident of cosmic geology, a confluence of volcanic activity, erosion, and time, all working together to create this stunning formation. It's a visual anchor, a geological puzzle that demands we ask, why does it look like that? What forces shaped it? What secrets does it hold? And that question, that insatiable curiosity, is where the real adventure of Martian exploration truly begins. It's a journey into the heart of a planet's past. How did those stripes form? The leading theory: fractional crystallization. As magma cools, dark, dense minerals crystallize first and sink, forming dark bands. Lighter minerals crystallize later, creating pale layers. This process repeats: new magma injections, cooling cycles, building up the striped pattern. Each band is a barcode, a physical record of volcanic pulses and changing conditions in an ancient Martian magma chamber. The thickness and composition of each stripe reveal the chemistry and timing of these events. Zebra rock isn't just a pattern, It's a timeline, written in stone. By reading these bands, we're peering into Mars's volcanic past. It's geology's version of time travel. Jezero Rock isn't just a pretty find, it's a window into Mars's volcanic history. Its layered structure shows that Martian volcanoes weren't simple, they had complex, long-lived magma chambers much like Earth's. By analyzing the rock's chemistry, scientists can date volcanic activity and understand how it may have interacted with ancient lakes. Did volcanic heat help keep water liquid? Did gases from eruptions change the Martian atmosphere? Jezero Rock helps answer these questions, revealing the inner workings of Mars's fiery past. It's like reading the diary of a Martian volcano. Have we seen rocks like Jezero Rock on Earth? Absolutely. On Earth, similar banded rocks, layered intrusions, form in ancient magma chambers like the Skaergård intrusion in Greenland or the Bushveld complex in South Africa. These earthly twins confirm that the same physical and chemical processes shape both planets. Studying them gives us a playbook for interpreting Martian geology. It also hints at Mars's potential mineral resources concentrated by the same processes. Jezero Rock proves we're not starting from scratch, we're building on generations of geological knowledge. How do we know so much about a rock millions of miles away? Perseverance is a rolling geology lab. Its Watson camera takes ultra-detailed close-ups revealing the rock's texture and mineral grains. PXL, an X-ray spectrometer, maps the elemental composition: iron, silicon, magnesium, and more. Sherlock uses lasers to identify minerals and search for organics, going beyond elements to molecular structure. Together, these tools create a detailed chemical and mineral map of Jezero Rock. Each scan adds a new layer to the story, letting scientists unravel Mars's history from afar. It's remote science at its finest. The initial data analysis confirmed the basics of our hypothesis, aligning with established geological principles. We meticulously examined the information transmitted back from the rover, cross-referencing it with existing models of Martian rock formation. The dark bands, as expected, are predominantly rich in iron-magnesium pyroxene, a common mineral found in volcanic rocks. These dark bands provided an initial clue to the rock's origin, suggesting a possible link to ancient volcanic activity on Mars. Conversely, the light bands are abundant in plagioclase feldspar, another key mineral component often associated with igneous rocks. The presence of both pyroxene and feldspar pointed towards a specific type of magmatic process. This mineral composition strongly suggested classic fractional crystallization, a process where different minerals solidify from magma at varying temperatures, creating distinct layers or bands within the rock. But as we delved deeper into the data, there were surprises that challenged our initial assumptions and opened up new avenues of investigation. One of the most notable anomalies was the unexpectedly high phosphorus levels detected within certain sections of the Jezero Rock. This elevated phosphorus concentration hinted at the possibility of water interacting with the magma during its formation, a process that could significantly alter the rock's composition. Furthermore, the large size of the crystals showed that the rock cooled slowly, deep underground, allowing ample time for these large crystals to develop and grow within the molten rock. This slow cooling process was inconsistent with a quick surface eruption, suggesting a more complex geological history than initially anticipated. Perhaps most intriguing of all, the Sherlock instrument detected the presence of carbonate minerals, a discovery that added another layer of complexity to the story. The presence of these carbonates provided compelling evidence that water, at some point after the rock's initial formation, flowed through the rock, depositing these minerals within its cracks and crevices. Therefore, Jezero Rock's story isn't just about fire and volcanic activity, it's a story of fire and water, intertwined in a complex dance of geological processes. It paints a picture of a dynamic Martian environment billions of years ago, where volcanic activity and water played crucial roles in shaping the planet's surface. Each new finding added complexity to the narrative, revealing a more intricate and fascinating history than we initially suspected. It transformed a seemingly simple striped rock into a detailed record of both volcanic and watery processes that occurred on ancient Mars, providing invaluable insights into the planet's geological evolution. The more we learn about Jezero Rock and similar formations, the richer and more detailed the story of Mars's past becomes, revealing a world far more complex and dynamic than we ever imagined. It's becoming increasingly clear that Mars's past is far more dynamic and geologically active than we ever imagined, holding secrets that are just waiting to be uncovered. Whenever we find water on Mars, we ask, could there have been life? Jezero Rock's story of fire and water makes it a prime candidate for past habitability. Long-lived volcanic heat could have powered hydrothermal systems, hot springs or vents like those teeming with life on Earth. Water flowing through the rock created chemical gradients perfect for microbial metabolism. Cracks and pores inside Jezero Rock could have sheltered microbes from harsh surface radiation. No evidence of life has been found yet, but Perseverance has collected a sample for future analysis on Earth. Jezero Rock points us to the right places to search for ancient Martian life. It's a giant, striped signpost for astrobiology. Jezero Rock didn't just excite scientists, it captured the world's imagination. Its bold stripes made headlines, memes, and fan art, turning Martian geology into a viral sensation. The nickname made the discovery accessible, sparking curiosity in people of all ages. Educators used it to teach complex geology in a way that felt real and immediate. Public excitement builds support for space exploration and reminds us that discovery is a shared human adventure. Jezero Rock became a mascot for Perseverance, connecting classroom science to the cutting edge. It's proof that even a rock can inspire global wonder. The story of Jezero Rock is just beginning. Perseverance has drilled and cached a sample from a similar rock, now sealed and waiting on Mars for a future return mission. NASA and ESA plan to bring these samples back to Earth, where we'll analyze them with powerful lab instruments. We'll uncover details about Mars's volcanic and watery history and maybe even signs of ancient life. Jezero Rock has given us a treasure map. Future missions will target similar formations. The real adventure starts when these Martian rocks arrive on Earth. The next chapter is about to unfold. One striped rock has supercharged our understanding of Mars. Jezero Rock is a time capsule, revealing a world of fire, water, and possibility. It's a testament to why we explore, for discoveries that change our perspective and spark new questions. What secrets do you think Jezero Rock is hiding? Is it a signpost for ancient life or a geological marvel? Drop your theories in the comments. I love reading them. Thanks for joining this deep dive. Stay curious and keep exploring. If you enjoyed this deep dive into Mars, don't forget to subscribe, like, and comment below. Your support helps us bring more space mysteries to life. Hit that subscribe button, give us a thumbs up, and share your thoughts in the comments. Every click fuels our journey to the stars. Thanks for being part of our cosmic community. See you in the next adventure.